Welcome to the Climate Hive show, What Do You Solve? I'm Kevin Drolet, aka Kedro, and I'm here with my co-founder and co-host Mike Higgins, aka Higo, who's now a grandpa. Isn't that amazing? Today, we're
True.
excited to travel across the pond to the UK to speak with our guest and friend, Stephen Melbourn. Stephen is a physicist by training and a founder by trade, and Stephen has been growing an exciting and successful business his entire career. He is the founder and CEO of Nellie Technologies, and Nellie Technologies is pioneering bioengineered carbon dioxide removal solutions. And if you don't know what that means, don't worry, you're going to find out. They're actually building carbon capture and removal technologies to change the world, and Stephen's very passionate, so we're very much looking forward to this conversation. We hope you are too. And I am going to turn it over to my good man, Higo, to start the show.
All right. Hey, Stephen. So our show is What Do You Solve? So the question is the theme of the show, but we like to start with what we call the aha moment. So the aha moment is there's a pre-world, a world before Nellie Technologies, and then there was your idea and your inspiration, the assembly of your team, your partners, your coworkers, the execution of the vision, and now there's the post world, which has Nellie in it. So why don't you just take us through, that evolution of the aha moment from what gave you the idea and the inspiration and the motivation to say, now's the time, let's do it. I'd love to hear that story.
Yeah, I mean, it's a long story, so bear with me, strap in. Thanks for having me on the show today. Really excited to be here. And the aha moment was more like a aha decade, or possibly 15 years, actually. So one of my earlier businesses was a logistics company. So we ran a fleet of lorries and we had some warehousing, and the fuel bill got very, very large for our logistics company. This is maybe 15 years ago. And so I quite arrogantly or naively thought that I must be able to find a way to make biofuels to stick in our trucks to reduce our fuel bill. So I thought, well, how can we make biofuels? And I thought, well, microalgae is a great source of potential biofuels. Therefore, I'm going to grow some microalgae and I'm going to see if I can get some biofuel from it. So about 15 years ago, I designed a system to grow microalgal biomass at speed and at scale in our workshop, and made microalgae, but completely failed to make any biofuels, because anyone who knows the market for making biofuels or the technology for making biofuels from microalgae knows that it's incredibly difficult and incredibly expensive to do. So I thought, well, that was nice. I've managed to grow some green stuff that smelled horrible and I couldn't do very much with it. So that kind of went by the wayside. 15 years later, I've had a software business now for the last 15 or so years. Very happy with that, doing industrial software processes. And one of our clients at the software company was a Swedish engineering firm who operated a site here in the UK. And we were working for them. And their engineers had a particular challenge to both reduce the CO2 emissions from their plant and monitor the CO2 emissions from their plant. And so they charged us with building a software package to measure the emissions profiles from their UK factory. But to be honest, I wasn't really that bothered about building another software package to do something that was really quite essential, when I thought I might have an idea to do something way more impactful of removing the carbon dioxide from either the atmosphere around their factory or from the pipes as they came out of the factory. And just as I was having that thought process and wanting to get my hands dirty again, because I really only worked from a computer for 10 years, the pandemic came. So the pandemic came, and we were very lucky at my software business that all of our clients kept us on our retainers, and we didn't really have to do much work for the retainers that we were kept on. So I had some spare time and I was going crazy in my house, not doing anything. So I thought, well, why don't we look again at building an engineered system for carbon dioxide removal? So that aha moment was about two moments, 15 years apart. The second nucleation of the aha moment was really driven by some public funding that was available to design, develop, and deploy environmental mitigation technology. So we took advantage of that, and 3 years and a couple of months later, we're here now.
Wow. What a road that was. But, out of the gates, you saying, oh, I decided I'll just, make some of my own fuel without, I'm just like, I'm not 100% sure that would have ever occurred to me.
I'm from the north of England, right? And in the north of England, for anyone who doesn't know what we're like, we're famously frugal. I think that's the polite way of putting it. So we don't spend a penny unless we have to. And yes, if we can find a saving somewhere, we will. So yeah, it was how can we cut down the fuel bill?
That's fantastic.
So could you also help us understand, like, from the standpoint of coming into it from a climate standpoint, and understanding that you're building the software, obviously, you've tried some things, but talk a little bit more about how the climate piece of that comes in, or like, hey, I can actually make a dent in this. Was that something you'd always felt passionate about? Was there something that was a moment for you, or?
Yeah, I mean, I think I'd reached a certain juncture in my life, really, I think, where I didn't feel like maybe I had enough purpose in what I was doing, right? So, no one's ever remembered forever, but I thought, will anyone ever remember any of the work I've done in my professional career with what I've done so far? And I thought, well, we've made a positive economic difference and a positive efficiency difference for our clients over the last 10 years or so. But would anyone look back at the work that I had been part of and think, actually, that really did something good at the time that it was needed most? So the purpose behind wanting to build this was to leave a legacy, if that doesn't sound too self-centered and narcissistic.
No,
You're good.
And I suppose it really came from, I have a set of skills, but I don't have all of the skills. So what could I do with my limited set of skills to make a positive climatic impact? And how could we turn it into a business that was self-sustaining? I think that was the most important thing, because I could have went back into academia and continue doing fantastically ambitious research projects, which we all desperately need. But in order to solve a problem that is in many respects driven by a commercial market, the solution needs to also be a part of that commercial market. So I thought the best way to do that was to build a technology, build a company, and deploy that technology and company to address that market.
Yeah, I think that's the way to build a company that's going to last, is, you have to integrate a commercial component to it. So in my mind, it's like you've got the windmill, you need the wind, and they work together, and you can't have one without the other if you want that energy to come about, and one of the things I've spent a lot of time on your site, and the headline banner that you have across the top is clearly your mission statement. I think it's really bold. It says, "We build technologies that fix the climate." That's a bold and worthwhile statement, and a statement worth being remembered for, right? So why don't we, at the Nellie level, give everyone that's listening an insight as to how you're doing that, right? Because you've got a very distinct process that I think is fascinating.
Yeah, and that's a great pickup. So thank you for that. So our sole purpose is to build those technologies that fix the climate. And it happens that our technology at the moment that does that is our bioengineered microalgae carbon dioxide removal system. So, the system itself, not to get into too much technical detail yet, but it's really, really straightforward. If it is a known that there is too much carbon dioxide in the atmosphere, so I think we can all agree, probably everyone who's going to watch this would hopefully agree, if there is too much carbon dioxide in the atmosphere, we need to find a sustainable and economically sensible route to remove that. Now, there are a number of carbon dioxide removal pathways. We straddle 3 of those pathways, actually. We straddle both DAC, which is direct air capture. So that's basically taking carbon dioxide straight from the air around us. And then we also straddle biochar. Now, I'll come into what biochar is, but that happens to be the end point of our process. So knowing that policy and science had decided that A, there was too much carbon dioxide in the atmosphere, and B, that there were a set of pathways to both removing that carbon dioxide and storing the subsequent carbon that came off it. How do we build a modular and scalable system that maps to existing science and existing CDR pathways, existing carbon dioxide removal pathways? So I suppose the nucleus of the idea that we could create this microalgal biomass. So basically, we never use the term tiny trees because it sounds a bit too simplistic, but in essence, tiny bits of green gunk, some green biomass, we can grow that really quick. As that grows, it removes that excess carbon dioxide from the atmosphere. We then take that gunk, that big green biomass that we've created, we dehydrate it, so we remove as much of the water in it as possible. And then we perform pyrolysis on that biomass. Now, pyrolysis is basically the process of heating any biomass to a really high temperature in the absence of a flame over a period of time. So it's like burning it, but without a flame. As you do that, you store the carbon in the product that comes out of the pyrolysis process. So instead of releasing the carbon dioxide again, if you were burning it for fuel, this biomass for fuel, you store the carbon in something that looks a bit like charcoal at the end of the system. And that's called biochar. And then that's where the carbon, the oxygen's gone back into the atmosphere, is stored for a very long period of time. Now, how long depends on a number of factors. I'm happy to bore you to tears with how long the carbon stays out of the atmosphere for and how we try and make sure it stays out for as long a time as possible. But that end-to-end system, basically, if you were involved in the carbon dioxide removal sector, you would probably understand our system end-to-end. You go, well, actually, yeah, we can see that we understand that any kind of organic biomass uses carbon dioxide. That's a good thing. And then you would also understand that in processing that biomass, we have stored that carbon for a very long time in a stable form. So the system, despite all of the really exciting and quite clever science that happens inside of it, is really, really straightforward. And that is great for us because it allows us to tell everyone about it and everyone kind of understands what we're doing, which is great. So we get to go to not just the market, but our local communities, our national governments and say, this is what we're doing. They look at it and go, yeah, we can kind of get what you're doing and we understand why. And the science pathways through the process that means we are taking carbon dioxide from the atmosphere and putting it away for a period of time.
It's kind of funny to me when you were describing it. I was waiting for, and then we add garlic and bits of clove, pepper, and salt. It was almost sound like it was you were cooking something up, tiny trees. And then, have you tasted the biochar? Is it no?
Yes. But that's part of our safe biochar handling methodology. So I have to say no. But accidentally, I might have tasted it once. But the stuff that we grow, a lot of it is food grade. So, microalgae is a really common food supplement and a food additive and a food source in itself. And we use several microalgal strains in different parts of the system and in different operating environments. But one of the ones that we always use, or nearly always use, is spirulina. Spirulina is a well-known microalgal strain, and it's a perfectly good food grade standard of microalgae. I, for one, can't stand the taste of it. I can't stand the smell of it. So every day coming into this lab is really a labor of love, but the emphasis on labor. And they do say you shouldn't touch your own gear. So, I don't use my own product. If you want some, you're welcome to it.
That's fine.
I like that you said, people come and they kind of get it, because I'm going to put myself in that category. Like, wow, at a high level, using nature, right, to absorb the material, and then you take that material and then you turn it into biochar, right, putting it under high heat with low oxygen, and out comes this biochar which is this reusable material now, right? So you're taking what was harmful in the environment, in the air, which is fascinating, and you're turning it into a physical product that you're holding. And now the biochar is product. On your website, it talked about that there's different things that you can do with this that are commercially viable, right? You want to give us a little insight into that and how that's working?
Yeah, so our entire, because we're purpose-driven on the removal and long-term storage of carbon, so we see the agricultural use of biochar as a soil additive and as a biofertilizer as one of the best ways for mass deployment of biochar, but also just because of the easy pathway to delivering that. It's also one of the most scientifically understood ways of using biochar to deliver that long-term sequestration. So there are many, many uses of biochar, some more advanced, some less advanced, some still in very early research stages. But the agricultural use of biochar, which is where our product goes at the moment, is well understood and well accepted as a really good route to long-term storage of the carbon that comes out of the system that we have. There are many, many other potential uses. We do have some exciting R&D projects going on biogenic aggregates. So that's where we might use biochar in the construction industry, cement, concrete, other kind of aggregates. There are other uses in the steel industry as a caulking replacement. There's instances for bioremediation where we can use it for filtering dirty water in sewage plants and water treatment. You know, I am a biochar evangelist. There are people who are far more passionate about biochar than I am. I see it as a tool to deliver what Nellie is delivering, which is the carbon dioxide removal. And I
Right.
love that lovely black biochar that comes out of our system. And it just happens to be a really good way of storing that carbon. But yeah, so at the minute, we're entirely focused on the agricultural use of biochar for long-term carbon storage. However, that's not to say that we are completely devoted to that pathway. And who knows, in
Sure.
5 years time, depending on what the market needs, depending on what our customers require
Right.
and demand, there's all kinds of moving parts with how we deliver that carbon sequestration. And we will do what the market, I think, what the market demands and what the policy suggests and what the science requires.
Yep. And what emerging technology creates opportunities, right? You can mix it all together. Let me ask you, so once this is all fused together in that process and the biochar comes out, the carbon is at that stage, it's locked in the biochar, right? So you can take those, charcoal bricks, I have that in my mind, and you can crush it into dust and it doesn't release the carbon, right? Because it's all fused together, right? Because I'm thinking about in agriculture, would farmers like grind it and then till it into the soil? So is it a soil enhancement? Is that what it's for?
You know, that's exactly the question that people should be asking. So I'm really glad you did. So depending on the size of the biochar, now how you treat it, how you use it, and even how you till the soil, impact on how long the carbon will stay out of the atmosphere for. So if you have a chunkier biochar, it is less like, or it will release the carbon back into the atmosphere or store the carbon longer. The chunkier the biochar is. If you want to grind that biochar up, it will have a slightly better nutrient profile within the land that you're using it on, but the carbon will be released slightly sooner. So it's basic like mass balance analysis or a thermodynamic.
Gotcha.
You can't win on both sides. If you want that carbon to stay away for a long period or the longest possible period of time, you have to use the biochar in a certain way. You can use the biochar in another way, and it is still massively positive for the environment, but not quite as positive as if you use it in the prescribed route.
Gotcha. That makes a ton of sense. And one other question I had, just curious, when biochar comes out, right? It has mass, it has weight. What percentage of that weight is carbon? Is it 100%? Like is the entire biochar 100% carbon at that stage?
No, it depends what else goes on in the system. The exact pyrolysis route that you're using, whether you're doing slow or fast pyrolysis, what else you're looking to get out of the pyrolysis process. Because that pyrolysis process in itself generates things that you either want or that you don't want. And some users of a pyrolysis system might want it, some don't. So it depends on the exact setup that you're doing and how you treat the biomass in the pyrolysis system as to the carbon content that comes out in the biochar at the end. So the carbon content, the OC and HC ratios of biochar, that's really one of the core metrics of the quality of what we produce, and it's what we're assessed on. So we go through really rigorous due diligence, assessment, and audit processes, primarily to make sure we do what we say we are doing in a safe and environmentally responsible way, but also to look at the profile of the biochar that comes out of our system. How does it compare to other pyrolysis methods? How long, given the carbon content of our biochar, will that carbon stay out of the atmosphere for? So it sounds like on the surface, it's a really simple approach, but underneath it, there's some massively complicated calculations that we use along with some, we think, quite smart proprietary MRV software and stakes in the ground and sensor technology that we know from almost every site that we deliver biochar to at the moment. We know what the biochar is used for, how it is used, how the soil and land is treated, what the temperature profile, pH levels of the soil is like. And from that, using a set of calculations, we can give a fairly accurate estimation of how long the carbon will stay out of the atmosphere for.
That's yes, super interesting actually. So that makes me think this question I've had is like, can you, because I know there are companies that are producing biochar. I've talked to quite a few companies that produce biochar. And there's also companies that do, direct air capture technologies and these kinds of things. Some of them are controversial. Um, and, even the carbon market, sometimes that's controversial. But you're actually, you're growing something and then pulling the carbon and storing the carbon from the thing that you're growing, which is interesting. But what's separating you? Like, what's the separator of a company like Nelly from perhaps what some of these other companies are doing? Is it your ability to sort of see where the carbon's going as you were just speaking to? Is it your process? Without, I realize you can't tell us your deepest secrets, Stephen, but
Happy to. It's been a long day. It's morning for you, evening for me. I'm an
yeah,
open book from 5 p.m. So it's a really good question, and it's probably not to labor a point, but it's a longer answer than maybe you were either hoping for or expecting. So you
bring it
rightly
on. It's okay.
you rightly say that you could compare us to a direct air capture, a straightforward standard chemical absorption route direct air capture installation. And you could compare us to that because we are both in the business of removing carbon dioxide from the atmosphere. And I like that you call them separators rather than competitor analysis or USPs, because when it boils down to it, as long as there's a group of us CDR companies who are successful, then we all ultimately win, right? So we're not in the habit of kicking our friends and colleagues in the industry, because we are all, as a rule, working
Right.
towards goal. But if you were to compare us and look at our separators from the DAC industry or the standard DAC industry, in terms of you might see a shipping container, you might see some massive fans on a roof in Iceland, and that's real public perception of DAC. I think that's where it is. With that, we are, as a rule, cheaper, partly because our technology is just so much cheaper to operate, right? If you can explain a technology really simply, it's usually cheaper to build it and deploy it. And that's where we are. So our price point for DAC in terms of how much it costs is up for discussion, because none of us talk about how much it actually costs. We talk about how much we sell, that removal of 1 ton of carbon dioxide for. And I know from public figures that we are cheaper. So I know that for a start. With any carbon dioxide removal system, whether it be DAC or any other methodology, you always have to find somewhere to put that carbon. If you can't, well, it's not really sensible to just make a pile of carbon and stack it up in a car park somewhere. So traditional DAC companies, or maybe commonly understood DAC companies, might be doing liquefied CO storage in geological fissures under the sea. I think that's a really well understood way of doing it. It is very expensive to do that, in terms of liquefying the CO2 that you capture, transporting it from the capture site to the point of storage, geological sequestration under the sea, through pipelines, which require massively expensive maintenance, infrastructure, and people around that to keep those pipelines alive, active, and operational. We don't have any of that. So our biochar that we're doing on site here goes to a farm which is either next door or within 50 miles of the site. So even as we scale, most of the end product of what we're pumping out of the system is used within a relatively local environment. More than that, you can't just hook into something. At the moment, you will be able to, and pump your liquefied CO2 into a storage tank under the sea. And if you are, and when you are able to do that, you will require governmental permissions. So this is your stakeholders and the interested partners in your operations all of a sudden go from being someone who operates a generator or your local supply grid to being governments. Now, governments are liable to move a little bit slower than private interests. And so that can delay projects considerably for the traditional DAC route of chemical and then geological storage. So I thought it was a very long answer. I've only covered how our separators compare to traditional DAC. And then to the biochar operators, it's really, really straightforward. Everyone in the biochar industry is really passionate about biochar and the benefits thereof. So this is certainly no bad comment on anyone else, but we have a uniquely secure supply chain. So traditionally, if you're doing biochar production, you need that biomass to go into your pyrolysis system. You have this thing that looks like a big furnace. You have to be able to put biomass into that furnace. To put it in, you have to source it. And it's no longer just a waste stream. That biomass that most biochar producers are using is a commodity rather than a waste stream. There are other high-value uses for this biomass for which there is growing competition. So what does that look like in 3 to 5 years' time? if you all of a sudden you don't have the biomass in your process, your supply chain is really, really dependent on that volatile commodities market for biomass into the system. So our separator would be is we thought, well, no, let's not talk to people about getting the biomass. Let's just grow our own.
Apart from biochar, clearly, let's talk a second about carbon credits, because it seems that's also an alternative revenue product for you guys, right? You've had some good business with Zurich. Why don't you, you know, is there, from when you make a carbon credit, are there different quality ratings depending upon, the biochar formula you used, that particular time? Like, how does that work? And do you see this as remaining as a revenue pillar for your business?
Yeah, I mean, just to clarify, the sale of carbon credits, or as we call them in the voluntary carbon market, and depending on who is doing all the checks and balances, who's looking at your system, we generally refer to them as carbon dioxide removal certificates, or CORCs for short. So,
Yes.
which helps in my wine analogy actually when we start calling them CORCs. But yeah, so we generate. And actually, aside, it's not our adjacent or additional revenue stream. The CORCs will be our main revenue stream, and it's what the system is designed to monetize, is the generation and subsequent sale and retirement of those CORCs. It will always be, the business will always be geared towards the generation and sales of CORCs. The additional adjacent revenue streams are nice to have, but they're not the core part of it, because I personally see, and so I suppose it's Nellie's point of view, as the carbon markets as being not only a really efficient tool for delivering climatic impact, but also the only tool that we really have to deliver that climatic impact. So in terms of the quality, there's many, many different ways to do the kind of quality layer and the quality level and certification of the product. So within biochar, there are different certification bodies, different but quite similar methodologies. That's how you create the biochar. And then you're given basically an approval or not. Are you able to produce biochar, or are you not able to produce biochar? And that's where the certification goes for generating that carbon credit. Within that, as you quite rightly say, there's all kinds of detail about the biomass going into the supply chain. Where is that being sustainably sourced? Is the biochar being used in an honest, effective method at the end site, whether it be in agriculture or whether it be in construction? So yeah, there are all kinds of gradients, and there are different privately led companies in the market at the minute who will offer to provide ratings on biochar and other carbon dioxide removal systems. We've been really, really lucky, and that our ratings, I mean, we are fully audited and fully compliant, but in terms of the rating, the quality of what we do, the veracity in what we do, we've enjoyed significant success with people coming to see what we are doing. If you want to stand next to one of our systems outside in the rain, we'd love you to come and stand next to that. See how that biomass smells, see how long it takes to grow. Then you can look at how we dehydrate it, and then you can look at how we pyrolyze it and sequester it. And in that process of seeing what we do, you can see that we are doing exactly the job that we said we were going to do. So no doubt in the future, there will come a time when we might have to do a ratings process, but we've been really lucky that we don't operate in the dark. We're a very open company. The doors are usually open, like they are tomorrow when we have our site visit for any interested local stakeholders to come and see what we are doing. And you can see the work that we are doing and the veracity, the proof points in the carbon credits, the CORCs that we are generating.
That makes a ton of sense. I would love to come and see it. I mean, honestly, it would be a fascinating thing to go and walk through and see. I think that you have such a unique idea in terms of, growing the biomass yourself, so you're not dependent on a fluctuating, supply chain market, right? So you eliminate a huge problem there, right? Because supply chains can spike, they can go up, they can go down, right? So it creates that volatility, which makes them unattractive, particularly if you're doing things at scale. Because if you build a lot of infrastructure that's dependent upon ingredients, and then those ingredients become really expensive, it can, dramatically impact your business model overnight. But
That's
you guys have
exactly
taken
right.
that away. Yeah.
I'm a big fan of analogies, and one of the analogies that I have really ridden to death is our bakery analogy. So imagine we are a bakery, and we happen to have a unique set of ingredients and making the dough that goes into our ovens, which makes the world's best buns, right? So Nellie is a producer, bakery analogy of the world's best buns. So you could either be a baker and just buy the equipment and run a straightforward business where, you know, we buy all of our ingredients externally and we own our own ovens and then we sell the buns at the end of it. But what we've done is generate our own ingredient supply chain as well. And that just makes sure that we can continue to generate the same volume of buns. If this analogy is still holding up, tell me if it's not. We can generate the same volume of buns for the next 5, 10, 15, 20 years. Whereas if we weren't getting our own dough in, if we were having to buy it in from elsewhere, then we would be worried about price fluctuations in the raw ingredients going into the system.
I think that's the exact right analogy. Yeah, it's the right analogy because it's also your customers now can rely on you to have stable price, right? So, you know, all of a sudden the buns coming out of your factory aren't going to triple in price, you know, because there's always a downstream effect, right, with supply chain fluctuation. So I think that was a really...
That allows us to enter into agreements that we can offer a fixed price point for delivery in 1, 2, 3, 4, 5, 6 years' time. Obviously, there could be concerns with utility costs within that system, but they are a lot more of a smaller part of our economics than the actual raw ingredients that go into the process. So yeah, I think the bakery system, having tested it now for the 45th time, has stood the test. And it also works actually for when we explain how we sell our buns. We don't just sell one bun at a time. You know, we enter into a long-term agreement to buy a lot of buns over a long period of time. So you can think of us like a bakery that would supply to a supermarket or a hypermarket rather than a bakery that would sell direct to the customer. I like it. Thank you for this. This is good consultancy.
No, I love it. And I think you can make that your tagline just to get people to talk to you. Say world's best buns. Nellie Technologies, world's best buns. People be like, what do you do? Oh, let me tell you.
It has been said that I've got the best buns in the business.
Nice.
We're on Zoom, you know.
I wanted to ask you also, Stephen, like, so I know that you guys got a Zurich insurance group. You signed a 5-year deal, and you're going to be doing 17,500 tons of carbon removal with them. What does the long-term look like? Because it sounds like you have some things very nailed down. They're tested. You have this system nailed down. You even have little bubbly lamps behind you, which are very impressive. But what's the next 5 years look like from a scaling standpoint, and what are some of the challenges? Because obviously every company has a challenge. But what are you foreseeing as the challenges that you guys have to overcome?
Yeah, I mean, first of all, I'll lead with that we are incredibly grateful for Zurich for being our earliest adopter, our first client, and at a size and an agreement level which really acts as a proof point in our company, our process, our technology, and the team. So we'll always be very, very grateful to Zurich Insurance. And I think hopefully what they saw when they came and saw the site and really kicked the tires of the technology are all those proof points I was talking about. And that allows us that kind of vote of confidence in not just the business, but the technology and the deployment allows us to confidently scale the operation. So our target is 100,000 tons per annum from our next site by the end of 2028. There'll be some incremental milestones in between then. And then after that, we kind of reach a max efficiency on a system basis at around about 250,000 tons per annum. So at 250,000 tons per annum, the system is operating at its maximum efficiency level. So from that, nothing is infinitely scalable, but it is an eminently scalable system based on available land and utilities. So we will need around about 5 acres of real estate to deliver that 250,000 ton deployment. We will only ever deploy to post-industrial landscapes. So the socioeconomic benefits of doing that are really, really good because we're operating in an area where industry is understood and oft delivered. But also it means we're not doing any land repurposing. So we're not taking away land from civic infrastructure, from agriculture, food production, or anything else. We are using land that would only ever be used for industrial purposes, which is a really big part of our deployment plan. We're currently in the south of Wales and southeast Wales in particular, near to Cardiff. And the kind of post-industrial, it's not really post-industrial because we still have a massive industrial sector here. But what it means is that the infrastructure, the land, the pricing of the land, the utilities, the infrastructure that comes into that land all exists in a way that we can just plug our systems into the existing real estate. So it makes us really easily deployable, if not infinitely deployable. And that will allow us to reach megaton, multi-megaton, gigaton, if necessary, capacity within the next 10 years. I do want to temper that ambition, though, with a market reality. And this is a question we get asked. I got asked earlier today, what does your 2040 deployment look like? Now, that is like being asked what happens inside the crystal ball. But more importantly, we don't know what the market is going to require. So going back to my bakery analogy again, why we don't know what the world wants in terms of the volume of our buns in 2040. So we will scale to match whatever the market wants. So however many buns the market wants, we will scale to deliver that at the price point that the market needs. And that really answers your question about the concerns about the scalability. Is that market is driven by policy and legislation. Now, we're a tiny little organization and we have almost no influence. In fact, let's say none. We have zero influence on what the powers that be decide is our climate goals in 2032. We kind of have a rough idea because we're all in broad agreement of what that might look like, but we don't know for certain. So we will deploy and scale to whatever size the market needs, but it has to be driven by the market, which is driven in turn by policy. So once you get the policy indicators, once that price per ton and the carbon markets, the compliance trading scheme markets are baked into legislation that can't be changed, which is, everything can be changed. But once we have strong market indicators, that's the size that we will scale to. So I can tell you in 3 years' time, we know we'll be able to sell 100,000 tons, 100,000 corks every year, but likely a lot more, and we will scale to meet that demand, but we don't know exactly what the market demand is going to look like in 2040. So in 5 years' time, we probably will, but you come back to me then whether we're going to be building a 500,000 ton site or a 5 megaton site. I don't know.
I mean, the bun analogy is so good because it answers such a spectrum of questions, right? I mean, it's such a good way of helping us in particular sort of understand why that question doesn't really have an answer, right? We have to kind of wait and see because it's not dependent on you.
Just to labor that analogy, I suppose it's a case of, in the future, does the market follow the economics of a bun market where it's a nice to have, they're a discretionary spend, the buns, in the voluntary carbon market, the buns are discretionary. Or does it approach something that more looks like a utilities marketplace where we're selling a kilowatt hour of electricity, which everyone has to have this, and it's kind of capped by the government. So how does the market change? Will it change from a discretionary spend market to a compliance market? And we can adapt to both.
Do you see staying in the UK? What's your global expansion look like? Is that something you guys aren't quite there yet, or what's that look like?
The technology is delightfully geographically agnostic, which means we can drop it in most geographical situations. It uses, the main inputs in the system are power, which we use in the UK because it's dark a lot of the time to illuminate the system. It includes heat because we have to heat the system to a certain level, and we use a lot of water in our processes. So if you think of the three main costs within the system as land, as electricity, and water. They are the three main costs in the system. So if we deploy it here in the UK, we have an okay electricity price. We know roughly what it is. Our water costs are quite low, relatively low, because we have so much of it. And our land costs are relatively high because of the kind of island nation that we live in. If we were to deploy in, I was in the Middle East last week. If we were to deploy to an area, like in Qatar, just outside of Doha, there's enough land there to do it. The land is outside of Doha is relatively inexpensive, so it's cheaper than it is here for us. The electricity is cheaper, but the water is way more expensive. So wherever we put it, we estimate that the economics will be roughly the same. Our cost per ton removed will be roughly the same, because that triumvirate of input costs into the system kind of adapt to give the same figure no matter where we put it. So that's the kind of techno-economic side of how we will deploy. Realistically, I see us having, or we are intending to have, a deployment in continental Europe. So within the EU, number of reasons there. We need access to a bigger biochar market. So we will be producing so much biochar that we need to find new homes for this biochar, and it can't just be in the UK. Also, it will allow us easier access to the EU's emission trading scheme, which we may or may not have access to as a British company. It's another policy aspect that we don't know.
Yeah.
And then in order to scale as rapidly as we can, I think the easiest route is probably licensing. We have a technology and we've built the system in a way that it will drag and drop and fit really easily into some established industries like the fertilizer industry. So if you were running a fertilizer operation or any kind of biofermentation company, you would look at what we are doing and you'd say, yeah, that makes sense. We can probably integrate that into our system. We could license that technology and integrate it into our business model. And I see that's the quickest route to global impact for the business and the technology.
I was going to ask if you would consider scaling the bun process. And it sounds like you would. You could go in and help them set it up and then do it that way. I think that makes a lot of sense because that's really when you can hit a different level of scale, right? When you're not having to do it entirely yourself, you know?
And, you know, we will never know every market inside out, and you need local knowledge. It's really crucial that you bring local stakeholders into the operation that you're doing. So when we have our open days and when we present in our local community, in our country, we know how to present that. We know how to hopefully sell our story that brings people along, but we wouldn't be arrogant enough to think that we could go to another part of the world and sell the same story and expect the same uptake, because every operational scenario was different. And I think that's best served by a partner who knows the local market.
Well, thank you, Stephen. That was a fun and fascinating conversation. Of course, we're speaking with Stephen Melbourn, CEO, founder of Nellie.Tech. They have developed a method for scalable carbon dioxide removal using homegrown algae-based biomass and converting it into biochar for long-term storage. And we learned a tremendous amount talking with you, and we really appreciate your time. Thank you very much.
Thank you both.